Hey everybody, welcome to the definite integral. We're going to be talking about midpoints. So this is video 3. Okay, using rectangles to find the area under a curve. We're flipping with Bennett here. I'm Bennett. So let's look at the definition here. So again, this is when we have the same width of a rectangle, b minus a over n. A and b are the endpoints. Okay, it's where you're taking the area under the curve of the first point and the left and the right endpoint, and n is the number of number of rectangles you're going to use. And what we're going to do is just basically take the halfway that we're going to take halfway between our two endpoints, and I'll show you how that works. That's why you have 1/2, 3/2, 5/2, and the formula is 2n minus 1. So watch what happens here. So this is for the midpoint when we have the same width. Let's look at a pretty easy example. Again, we're using the same example for all three of these. That's pretty common. You have the curve, approximate the area under the curve of x squared from 0 to 4 using 4 midpoint rectangles. Okay, so we're going to be using midpoint. So I know that if I have 4 rectangles, if you've watched the other examples, okay, notice here we have the midpoint of each rectangle in the middle, and there's not much overlap. This is an increasing function. If you watch the right Riemann sum, there was a ton of triangle over the function. So this is going to be a better estimation than the right Riemann sum right off the bat of this increasing function. Okay, so I'm going to find delta x first. So delta x is just b minus a over n. Delta x represents the width of each rectangle, okay, on the bottom. So we're just going to have 4 minus 0 over 4 because they asked us for 4 rectangles. Okay, so that's our width. Now, remember what I did for all of these. I go ahead and start on my left, and I say the width is 1, so 0 to 1. 1 to 2, 2 to 3, 3 to 4. Now, what was awesome on the left side, if I wanted to do this, video 1 was using these values. Video 2 was using these values, and video 3 is the halfway mark of each of those values. So watch the area. The area here is going to be 1 times f of, what value do I use? Halfway between 0 and 1 is half, plus halfway between 1 and 2, 1.5. Plus halfway between 2 and 3, 2.5. And halfway between 3 and 4 is 3.5. So that's where I get the heights of each of those rectangles. Okay, and now I've got to plug those in. Okay, so when I do that, I got to get my paper here so I don't screw up these values. I get 0.25 plus 2.25 plus 6.25 plus 12.25. And that's when I square each of those. 1/2 squared is a quarter. 1.5 squared is 2 1/4. 2.5 squared is 6 1/4, okay? So that becomes 21 if you add all those numbers up. Again, so with right Riemann sums that with 4 was 30, and then with 8 it was 25, and now look, with 4 with midpoint it's 21, so it keeps getting lower. Okay, so my last example is, you guessed it, same example, 8 rectangles. Okay, and notice on each of the videos, we know that with its 8 rectangles on an interval from 0 to 4, our delta x is 1/2. So delta x is 1/2. Okay. Now, if I was going to do that and list all those points, remember 0 to 0.5, 0.5 to 1, 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3, and 3 to 3.5, and 3.5 to 4. So my start is at my left endpoint, and then it way down to my right endpoint. Remember, first video left, second video right. Now we're halfway in between. So halfway between 0 and 50 cents, that idea, it's a quarter, okay? So we're going to have a quarter here, okay? The one that we want here is 0.75, all right? Then 1 1/4, and then 1.75, right? And then halfway between 2 and 2.5 is 2.25. And then halfway between 2.5 and 3 is 2.75, and then 3 1/4 and 3.75. Miss Kelly, would you like to say hi? I'm almost done. Oh, look, you're behind me in the video. Say, oh, wait, I blocked you. I got to go the other way.
No, it's okay.
There we go. All right, so now all those values here need to be plugged in and multiplied by 1/2. All of these. Okay, so when I actually do these out, I get 0.0625, 0.5625, right? 1.5, 1.25 squared. Okay, 1.5625. Okay, 3.0625. Okay, we're trying to hurry up here. So you just plug all these values in and you're going to square those into the function. And so we're going to add all these up, and don't forget to multiply by 2. And the last one would be 3.75 squared, which would give us 14.0625. So you're going to take this sum, okay? This sum ends up being 42.5. If you add that up, all of these added up. And if you take half of that, you're going to end up with your area, which is approximately 21.25. Okay, so again, that's going lower than the previous, a little bit higher actually than the previous example, but that's how you take the midpoint Riemann sum of a function. Okay, you go halfway in between your endpoints. All right, so if you have any questions or comments, let me know, and we will see you next time. Say bye, Miss Kelly.
Bye.